practice A for section 4.1, we're going to classify the triangle by its sides. If you look at the three sides of this triangle, you can tell that they're all congruent. They all have a length of 4 meters. That's what that M is. This isn't a length of 4M, it's 4 meters. If all the sides are congruent, then you would call this an equilateral triangle. Now, this isn't going to happen all the time, but in this specific case, equilateral triangles must be acute. These angles, since it's equilateral, these angles must be the same as well, which means they're all 60. So this is an acute equilateral triangle. Every acute equilateral triangle in the world will have those three measures, 60, 60, 60. In number 2, we have two congruent sides. Both have a length of 6 centimeters. This side is not the same length as that one. This is an isosceles triangle. And it's possible that isosceles triangles could be acute, like this one. It sure looks like this one's acute. All of the angles are acute. You could also have an obtuse isosceles triangle. We'll see that at some point on this worksheet. Number 3, all these side lengths are different. So this is a scalene triangle. You could also probably go a little bit further and recognize that this is an obtuse angle. So you can call this an obtuse scalene triangle. Scalene triangles can also be acute. Or scalene triangles can be right as well. Here's a triangle with two congruent sides. We don't know how long they are, but that doesn't matter as far as the classification goes. This is isosceles. And it's also acute. All of the angles are acute angles. They want you to classify these triangles by their angles now. So up here we classified by their sides, and in turn we actually were classifying them by their angles as well. But here they're giving you the angles, and they want you to classify the triangle by angle. Now I'm going to show you how to classify by side also, even when you only have the angle measures. So if you would classify this by its angles, we have a right angle. So it's definitely a right triangle, and that's really all they wanted you to do here. But I'm going to tell you that you can go a step further. Notice how all the angles are different. If all the angles are different, then all of the sides are different too. So it's going to be just like this triangle where all the sides are different. It's going to be scalene. So this is a right scalene triangle. If you wanted to, you could call it scalene right as well. That doesn't matter. Now, this one is 30, 60, 90. There are other right scalene triangles. All you have to do is just change these acute angles just a little bit. Number 6, we're classifying by angle. They're all acute angles. So it's an acute triangle. If you want to go a little bit further, notice how all of the angles are different. So it's scalene. Scalene acute, acute scalene, whatever you want to call it. These angle measures, they don't always have to be like this. They can be a little bit different. As long as they're all less than 90 and all different from each other, it would be scalene acute. Number 7, we have an obtuse angle. So this is definitely an obtuse triangle. And that's all they wanted you to do. But also notice how two of these angles that are acute are the same. So that makes this obtuse isosceles. So remember how we had acute isosceles examples up here? You can also have an obtuse isosceles. That's when your vertex angle is obtuse. Number 8, all of the angles are 60. So it's definitely acute, but at the same time you can call it equilateral. If all the angles are the same, all the sides are the same. 9 through 11, we're going to find the missing value of x. Okay, so we have a triangle angle sum theorem that tells you all of the angle measures of a triangle sum 180 degrees. So if this is 90 and that's 35, you can always find the missing angle. Okay, now we also have another theorem that tells you when it's a right triangle that these two angles are complementary. So you could just do 90 minus 35 to get the missing angle measure here. In this one, it's not a right triangle, so you can't use that little shortcut, but you could do the triangle angle sum theorem, 180 total, take away 125, take away 20, that gives you 35 left. This is 145 degrees. You need 35 more to get the 180. Here's a right triangle. So classifying it helps. So maybe I'll say right. Also, notice how the acute angles, we know they got to be complementary, but they're also congruent. So that makes this a right isosceles triangle. There's only one right isosceles triangle in the world. Think of two measures that add up to 90 that are both the same. Well, they're both 45, 45, 45, 90. There's only this right isosceles triangle that has these angle measures.